Welcome to Control Panel Pro, a complete training course I've just released for free here on YouTube and within our community. In this course, I'm going to walk you through exactly how to build the control panel that you see behind me from start to finish, step by step, no stone left unturned. And this isn't death by PowerPoint. This isn't theoretical crap that you learn in college that doesn't actually apply in the real world. This is the exact method that I've used to build hundreds of real world control panels across smart homes, commercial BMS systems, and industrial automation projects. So whether you're an electrician looking to upskill, an engineer breaking into controls, or a business owner wanting to train your team, this training is packed with real world practical insights that you can apply straight away. And throughout this course, I'm going to be referencing tools, templates, and extra resources to help you get the most out of it. And you can access all of these inside our free community where we help individuals and businesses level up in controls and automation very quickly. So you can find the link in the description. Let's get into it. So first thing, guys, before starting to do any marking or anything like that, what I'd recommend is a good old wipe over with methylated spirit and a lint-free cloth, something like that. So that's the first thing. So as you'll see, there we go, quick wipe over. This is what I'm doing now, is I'm just marking those dimensions, and you can see those dimensions on the drawing that I'm referencing, which is within the drawing pack, PDFs, and then BMS School Refurb, page 16. So you can see that's what I'm referencing whilst making these dimensions. And you'll also notice that I'm working off only two datums. So I'm working off this face and this face. I'm not working off this top face or this right hand face of the door either. So good practice, guys, is to always work off one datum edge for one axis and the same thing for the other axis. And the reason for that is it just keeps things, nothing's ever perfectly square, and I'm probably being a bit pernickety here, but it's just good practice. So I'd recommend always working from one datum, and it just keeps things square and parallel. And if you're unfamiliar with the term datum, so if we look in Wikipedia, when talking about engineering, an engineering datum used in geometric dimensioning and tolerancing is a feature on a subject used to create a reference system for measurement. In engineering and drafting, a datum is a reference point, surface, or axis on an object against which measurements are made. So that's what a datum is. So I'll mark a couple of points on each axis, and then what I'll do is I'll get the meter rule and then connect those points up, so then I can draw a complete line, as you're seeing here. And I don't double check, I triple check things. So before I move on after doing dimensioning, I just triple check and absolutely make sure that all the markings are perfectly okay. Reason being is usually you're marking things because you're going to be cutting them or drilling them. Really want to avoid drilling or cutting doors or enclosures in the wrong place. And really it just applies to anything that you do. It's worth just that small extra piece of time, triple checking your measurements before moving forward. So I really recommend doing that. It's totally worth it in the long run. There's been plenty of times where if I had not triple checked, I would have continued drilling, cutting, and then realized that things were out of place. So this has really saved my bacon plenty of times. So I really recommend doing it. So yeah, you can kind of see what the front of the door's looking like now. Just pencil marks these are, which tie up with the dimensions on that drawing. You'll also see in a second that I'm now going to clamp my meter long rule down on that edge, which I can then use as a guide edge for these plastic plates that go on the front, and then mark the plastic plates out. So yeah, clamping that meter rule, adding in the plates. You'll also see me add another rule down on this edge or this axis, So yeah, here I'm just making sure that all the plates are tight up against this guide and obviously pushed against each other. I'm also double checking it's the same in the other direction, and then as I mark the holes, the 22mm holes and the corner mounting holes, I'm just making sure it's all tight and nothing's moving. As you can see, my other hand here, just keeping it all tight and just working my way through them. And then even though I've gone through everything in the design phase, I just want to be absolutely 100% sure that the physical components, when they're going to be mounted on the door, they're not clashing, there's enough space and they just look okay. So that's what I'm doing here, just to, again, double, triple check before drilling or cutting. Okay guys, so I'm obviously filming this now after the fact, but I'm going to talk you through what I'm doing here. So yeah, first of all, you can see I was trying to use the compass method and then remembered how crap it is. So yeah, as you can see, this method requires cutting out a 22mm hole with a 22mm hole saw of the panel to start with if you don't have one already. So as you can see, this is what it looks like. For the first one, just measure it using a tape measure or rule, find the center tap it, drill it, and then deburr it, because there'll be some edges on it, deburr it, and then you can start using it how I'm going to be using it. You can see the first three that I tested out here, they are pretty bang on. So here's me now just testing those first few, double checking with the tape measure to make sure they're all right, but you can see visually that they're good. So yeah, here you go, you can see how perfect it is. Absolutely bang on. So you just hold it and draw with a pencil that centre bit. There you go, there's the pencil drawing that centre bit. So yeah, proof of concept. So I'm just going through every hole now, or every 22mm circle, and marking the centre there. As you can see, this is what it looks like when it's all done. You can see they're all absolutely bang on. And there you go, thumbs up. Good result. So as you can see here guys, I'm just going over all of the holes, the large ones and the small ones, and center tapping or center dotting, however you want to refer to it. So we've got a good solid indent for the pilot drill to start off in. So yeah, as you can see, center tap, center dot, and a hammer, and it's just a matter of finding the center of all of these holes, the large ones and the smaller ones. So yeah, just making my way through doing that. So yeah, as mentioned, next bit is the pilot drill. So this is 1.5mm that I'm going to go in with first before drilling out the main hole size. So you can't really see it here when I play the video, but as I mentioned earlier, I'm angling the drill and the drill bit to find the perfect center. If the center tap is slightly off center, I'll sort of move the drill and manipulate that center hole to the center, or as best as I can anyway. So yeah, pilot drilling all of the corners of those plates and the centers of those 22mm holes for the cam switches and indicator lights. So yeah, just to go back a step guys, you can see here, this is what the center taps look like. Pretty self-explanatory. So here you can see on the smaller holes, like this one for example, it's pretty much bang on, but I would be angling the drill slightly just to make that more central whilst doing the pilot hole. So yeah, just using standard drill bits, nothing special. And yeah, this is what it looks like when all the holes have been pilot drilled. So yeah, let's just finish off that drilling for the pilot holes. So yeah, the next step guys is the 3.2mm drill bit. So for the actual hole size of the corner of the plates. So yeah, as you can see, drill all of those out first. And those holes are for these snap rivets, the 3mm snap rivets that you can find on the parts, hardware and components list. And I've just got these from RS, but this gives you a good idea of what they look like. So yeah, and then once you push them in, this bit here expands and holds that rivet within that hole. So these are 3mm and we're drilling at 3.2. So there's that bit of clearance to get the rivet through the plate and then obviously into the enclosure door. So yeah, do all that, clear all the swarf away. So yeah, as you can see here, the next bit now is drilling out the larger two 22mm holes for the indicator lights and cam switches. This is what I'm using here, obviously a drill, an Armeg or Starrett hole saw. Those are the two I'd recommend using. And then very important, guys, to use some cutting oil or cutting fluid. So I just use some WD-40 specialist cutting oil. And using this cutting oil is just going to help the hole saw cut a lot better and also prevent it from going blunt and extending the life of it. So yeah, the hole saws that I've had last a long time because I always use them with cutting fluid. And also the technique that I use is I don't just go full pelt through the door. I sort of ease on and off the pressure as I'm going through, and that allows the swarf to clear and also more cutting fluid to sort of get in to the teeth. Yeah, it just makes for a nicer cut and yeah, prolongs the life of the hole saw. But obviously it does get a little bit messy, hence why I brought out the kitchen roll and gloves. So I started off by going through the holes all the way, and then I decided I'll use the smaller drill within the center of the hole saw first, and again kind of do a pilot hole and then go back and do the actual hole saw, the 22mm hole. So that's what I'm doing here. Clear away the swarf and then yeah, go back and do it properly with the cutting fluid and the actual hole saw. Yeah, and then once that's done, it's obviously just clearing all the crap away and then just giving it a good old clean with some methylated spirit and yeah, lint-free cloth or a rag, but just want to be careful not to scratch the paintwork, certainly on the front with dragging bits of swarf around, so just be careful of that. So yeah, just some photos of what it looks like when I'm using the cutting fluid. Yeah, I just squirt a dollop around each hole saw. There you go, that's what it looks like. Be sure to wear eye protection, certainly if you're not using cutting fluid, because I've had it before, even using glasses where swarf kicks up and has gone in my eye before, so I choose to use goggles, much safer. And yeah, my nice dustpan and brush here for clearing away the swarf. Oh, and as you can see here, I've added in a screwdriver because what you'll find is the section that you cut out occasionally gets stuck in here, so you just need to shove a screwdriver in one of those holes just to pop it out. And then yeah, final go over with a clean cloth, or relatively clean cloth, lint free, microfiber, whatever you want to use. And yeah, just go back over it with methylated spirit and give it a final clean. So onto the deburring, guys, and you can see this first bit, I'm just going around with the drill and a countersink and just taking the slight edge off the small 3.2mm holes. So yeah, you can either use one of those twisty countersinks or a bit that you can put in a drill. Obviously quicker just to put it in a drill. So then, yeah, as already mentioned, guys, just go through all those 22mm holes and, yeah, get the deburring tool and go around them. Just be careful on this face. You don't want to slip and scratch it. Yeah, and then it's just a matter of cleaning it all off, getting those marks off, and, yeah, then you're ready to go. By the way, if you want those extra wiring diagrams, parts lists, and extra resources that I'm mentioning in this video, they're all waiting for you inside our free community. You'll get support, guidance and access to loads more trainings as well to help you level up fast. So hit the link in the description, don't miss out. So yeah, on to mounting the plates. So pretty self-explanatory mounting the plates. These snap rivets, as you can see here, snap rivets. If you wanted to find the part number and where those snap rivets are from, you can find them in the parts, hardware and components list in the Academy and go down to row 128, and you can see here they're from RS. So let me show you. There we go. So yeah, 3mm snap rivets, and it's just a matter of drilling a hole 3.2mm roughly, and then once you snap those down, obviously this bit will expand and yeah, hold those plates in place. So yeah, just attaching all the door plates, another satisfying part, and then just giving it a clean with some methylated spirit and a lint-free cloth. So yeah, this next bit, guys, I'm just removing the Schneider door key housing because currently it's upside down. So yeah, as you can see here, because we flipped the panel 180 degrees to accommodate those removable cable entry plates to be at the top of the panel as written in the spec, it's made that Schneider housing for the key lock upside down. So that's what I'm doing here. I'm just switching that over, trying to work out how to use some pliers or grips. There we go. Can't even call them what they are. There we go, so that's sorted now. Now the next stage that you're about to see is going to be just fixing all of the indicator lights and the cam switches. And these cam switches from Schneider, you can clip them together and they're relatively loose, and then you need to tighten them to make them clamp into the door. But at this stage, I just click them in, and as you'll see in a minute, I just reverse the door around the other way just to check that everything lines up before tightening everything properly. It's the same with the indicator lights. I just do them finger tight initially, and you'll see why I do the indicator lights finger tight a bit later or in a second. So yeah, here you can see I'm just making sure that all these cam switches line up with the markings, so like hand off auto or on and off, just making sure they all look okay. And then yeah, there you go. At this stage, that's when I'm tightening the cam switches up and making sure that they're tight against the front of the panel. So yeah, as you can see, this is what it looks like when it's all tightened up and finished. And now the next stage, which you're about to see, is fixing the finger trunking on the inside of the panel, obviously to hold any cable that's coming in to feed the cam switches and indicator lights. So first thing, pretty obvious, is get these finger trunkings to the right length. Now on most larger panels, you see these holes here, you can actually get metal mounting plates that will fix across the door here, and then you can attach the finger trunking down on these metal plates. But for some reason I can't find them for this size enclosure, so I'm just fixing them directly, just using the trunking itself and the holes in the trunking. But yeah, for the larger panels, you'll be able to get something like this. Pretty simple, just a bit of metal that fixes across the door, as mentioned. So yeah, cut those to length, open up the holes if they need to be, just to get them lined up with these holes here. Potentially drill new holes in here if needed. If the gap that you've got, as you can see, this gap lines up nicely here, but if say the gap that you've got is in between two holes, then just drill some new holes. So the tools that I'm using for this part that we're working through at the moment is some rivets and penny washers, rivet gun obviously, these Phoenix Contact trunking scissors. They're quite pricey, but they're definitely worth it. And then yeah, drill bits, tape measures, pencil. So yeah, as I just mentioned, I'm having to open up the final holes in the trunking just so they meet and line up with the metal holes on those mounting brackets. So yeah, just a needle file, just a file like this works fine. You can see, just open them up like this and yeah, just file that bit out there if needed. So there you go, not perfect but good enough, and at the end of the day it's going to be riveted with a penny washer, so yeah, that's perfectly okay. And then here's a picture of the underside of the bracket where you can see that rivets spread out on the underside of that metal bracket. So yeah, there you can see fixed with a penny washer and rivet. Same on this one. So yeah, there you go, that's what it looks like with the trunking finished and mounted to the panel door. So yeah, final picture of the trunking cut and fixed using those penny washers and rivets. Now this final bit that you're about to see, this is where I mentioned earlier about not tightening up the indicator lights, just leaving them like finger tight. So yeah, you can see that I'm rotating them, getting them all the same orientation. So you can see they're all facing down. These ones aren't, but yeah, there's a terminal facing downwards. And what you'll see on these indicator lights that have 4 terminals, you've got T, which is test. So when we press that test button to test that all the lights are working, that's going to feed the T input or T terminal block. There you go, different angle. We've got the S terminal, which is the signal terminal to indicate if it's running, if it's in fault, and that'll be coming from a relay. And then you've got the C terminal, which is the common. So because these are 24 volt AC indicator lights, that'll be the neutral or 0 volts, however you want to refer to it. So yeah, you can see here another shot of the 3 terminals, and then I'll just make sure that they're all in the correct position and then tighten them all up. So guys, on to marking the backplate, and as you can see, first things first is give it a good clean with methylated spirit, as you can see here from this photo. And then the first thing I do, guys, is just mark lines along the backplate working from a single datum, so this bottom datum, and just going through the drawings of all these dimensions and mark them all at the same time. Then what I do is I use my meter rule and connect up all the lines. So I've marked the line at the right, the middle and the left, and then just connect them using the meter rule. So as you can see here, it looks something like that once it's finished. And then I will always double check or even triple check the dimensions after marking them. And then the next bit is to move on to the vertical pieces of trunking. So always start with the vertical bits of trunking. And as you can see, I've just marked this line here, which is for this first one. So yeah, it looks something like this as we make our way through. So yeah, now just working out the lengths and then cutting them. I'll also do the lids at this stage as well. You don't have to do the lids now, you can do them later, but I always do the vertical trunking lids at this time. I usually do the horizontal trunking lids a bit later. Okay, now you can see I'm starting to mark out the drill holes to fix the trunking. And now you can see I'm starting to work out the lengths for the horizontal pieces of trunking. So I'll do the horizontal bits of trunking after doing the verticals, because what you'll see in a detailed video from me is it's always good to keep a bit of space between the vertical trunkings. So that's why I do it that way round. And vertical trunkings are always kind of like the master pieces of trunking, I think, in terms of length. So again, you can see I'm starting to mark out the centres of the holes over here. Now doing the same thing, getting them to length over on the right hand side and marking out the centre drill holes. And you'll notice here, guys, you've got like L3, L2, R2, R3, R4. Now I do that because what it does is it just speeds things up slightly when I come to put the trunking back on. So without these labels, and I'll label the back plate as well, when I come to put the trunking back on, I know that L3 goes here, not here. Even though they're going to be probably the same length, the holes might be slightly off. So I just do that, just makes life easier. Yeah, so now we're kind of at this point here. We've got all our trunking marked out and cut to length and the holes marked as well. Now the next bit is the din rail. So it's a similar thing with the din rail. So yeah, as you can see now, I'm just starting to do a similar thing for the din rail lengths as well. So yeah, just cutting the lengths of din rail here and then making sure that they get deburred. And then yeah, just putting them back onto the back plate and marking those central drill holes. Again, similar to the trunking. So yeah, quick photo of what the din rail looks like before it's fixed on the right hand side, the BMS side of the panel. And then where we're up to now is we basically got all of the din rail and trunking cut to length, and we've got all these central drill holes marked. So first things first, guys, is centre tapping all the centres of the fixing holes which we're going to use. And then as you'll see here, I'm circling all of the fixing points which I'm going to drill. So we could have done this before doing the centre tapping. Ultimately, we don't need to use every single fixing hole. It's just complete overkill. So as you can see, I'm skipping one or two, having fixings each end of the trunking and then one in the middle. That's typically how I do it. And then here what you'll see is I'm pilot drilling all of those holes with a bit of cutting fluid. And then yeah, just a standard clean with methylated spirit, just get all of that crap off. So yeah, now just a matter of getting all the trunking and din rail in place and then starting to think about fixing it to the back plate. So as you can see, you could use penny washers for the din rail as well. I think it was just I didn't have enough to be consistent. I think I would have ran out about halfway through this side here. So I'm just fixing using tech screws, which is good enough for me. And then the actual trunking, I'm using penny washers. And I don't know if you can see it here, but I'm not tightening anything fully yet. I'm leaving it all a bit loose so they can move about. Also guys, very important this part, don't fix the outer bits of trunking, because, and I forget this every time, but you can see these little black notches here and here. Here you go, yeah, so these black notches you'll see that I'm doing now. There's another angle. What they are is they are for these sections of the back plate, and these sections of the back plate in each corner and halfway between each corner on the vertical and the horizontal, therefore fixing the back plate to the studs within the enclosure. So a stud will come through here and then we'll be putting a nut on the end of that. And we obviously don't want the finger trunking being in the way. So there's one of the middle cutouts. So I'll mark something like that. You see, yeah, enough to allow space around this fixing hole. And yeah, on the underside of that piece of trunking, it looks very similar. So yeah, going around just doing all of that. And then the best way that I found is not using a knife, not using cutters like this, because this trunking is very brittle and can crack in the wrong places. What I found is just use a hole saw. So yeah, as you can see, first piece of trunking, I've just cut out with a hole saw, this circular bit here, over the fixing hole. So what that looks something like this. So obviously drilling on the underside and something like that. Don't do it like this, because I've done it like this before and it just ends up cracking bits of the trunking where it's so brittle. So yeah, a nice little cutout like that, clearing that stud hole. So yeah, now just fixing those final bits of trunking around the edge. And then by this point, everything's still loose. So you'll see just then that I tipped up the back plate. So yeah, it looks something like this, guys. And then what I'll do is I'll put it on its side like that, move it about a bit. And what I'm trying to do is get all of the swarf and crap and metal and stuff out from underneath the trunking and the din rail. So I might do it on this side, I might do it on this edge, and just try and free up all that crap underneath the trunking and din rail before fixing it for good. So just did that then, and then as you can see, I'm going around with the drill with a torque setting enabled quite low and just going around and fixing everything for good. And now you can see just going through and just hoovering all of that swarf up. Also, another thing to point out, guys, and I found this quite a few times, is I would just visually inspect or run your finger, maybe not run your finger over, because what I'm about to say, if you find or notice a bit of metal swarf sticking up that could potentially cut into the cable, make sure you obviously remove that. So you might have to loosen the tech screw, pull it out with some pliers, and then just tighten it up again. So yeah, quick vacuum, get all of that cleared out. And then the final bit is snapping all the finger trunking, which is really, really satisfying. So as you can see, the finger trunking where there needs to be a gap for cables to move in and out of different trunking ducts, they obviously need to be snapped. So there you go, snapping finger trunking. And as you can see here, I always leave one finger on the end of a piece of trunking like this, and it just helps hold the lid in place better. So there you go, some more photos, very satisfying. And here's what I mentioned earlier about a bit of burr underneath the tech screw. So just make sure you go around and visually check and remove any of those little burrs. Those will definitely cause issues when you come to test later on, or even years down the line could potentially cause issues. So there we go, guys, that's what it looks like when it's all finished, ready for the components. Little mistake that I've made, and typical, I do this kind of thing most of the time. So if you look at the drawing, we're actually meant to have a laptop socket, or just a socket in general here, but I've made the din rail go across that whole section when it should have been cut off here. So that's something that I need to rework. There we go, so din rail should have sort of ended here. And it's exactly the same thing with the contactors and overloads and the transformer. As you can see, I've ran the din rail all the way along. So yeah, a couple of things that needed correcting there. So as you can see, this is what it looks like corrected. Very, very annoyed with myself because there's obviously these fixing holes, but as you'll see later on, I actually managed to cover those pretty well, so it's not too bad. If they were out in the open like that, I would be kicking myself and I'd consider starting again. That's how bad it bothers me. And here you can see a similar thing with the laptop socket. Again, luckily the laptop socket is actually covering this hole, so all good on this one.
Really quick, if you want the full parts lists, wiring diagrams and bonus resources I'm referencing, they're all inside the free community. It's totally free to join and there's loads of extra support in there too. Link below, go grab it.
Okay guys, on to fixing the components, one of my favourite parts. So starting off with the MCBs, initially fixing the buzz bar to the bottom. Now I've had a lot of people tell me, oh, you shouldn't fix buzz bars to the bottom, or you shouldn't fix buzz bars to the top. End of the day, it comes down to the MCB and the manufacturer. So check in the manual which way you should fix the buzz bar. A lot of them, it doesn't matter. And with these ABB MCBs, it doesn't matter. So I initially decided to do it at the bottom. Then I realized the path of the main feed. So I then switched it to the top. There we go. Switching it to the top, getting them all torqued up, and then getting those spare ways covered up. So next thing is filling that gap with the contactors and overloads and the transformer. So just marking that out, getting those holes marked, and then drilling and fixing. And you can see this center line for the din rail is higher than this din rail because these contactors actually sit on a din rail over here. And to have the combined contactor and overload central, we obviously need to move the din rail up. So that's just something to be wary of and considerate of if you're fixing components that have like an add-on, to make sure they then sit centrally within the trunking spaces. So yeah, center tapped, drilled, hoovered, clean that up, fix the din rail, fix the transformer, and then obviously fit the contactors and overloads. And as you can see, I've covered the holes, the holes that were there by mistake on this one. You see it's just on show here, which is a bit annoying, but it is what it is. Next bit is similar thing with the laptop socket, so just getting that fixed. And then two things with that. Number one, make sure you use these rubber grommets, so something like that. And also, when you're designing this, make sure that the laptop socket is as far up as possible, because plugs, they usually have that sort of flexi protector that stops the cable bending too much, which is quite rigid. So if the socket's too low and close to the finger trunking, it's very difficult to get that plug in. So make sure you keep the socket as far up as you can. Okay, then just adding the relays. And then next thing is working out what type of terminal block goes where along the power side of the panel and then onto the BMS side of the panel. So as you can see, some are triple terminal blocks from Wago, so live, neutral and protective earth, and then some of them are just standard single terminal blocks as well. So if you just saw then, I used a tape measure, so I was just getting a rough idea of where the main isolator needs to be mounted in relation to the door plates. And it's coming, and you can see the line there, it's very close to these terminal blocks here. So as you'll see, I need to rethink things. So as you'll see here, door isolator, the central bit here needs to align with this central bit here, and I want this bit here to align with that edge of the plates. So I'm working out the centre now of the main isolator, which you can see here. Centre of that should go here, but it's going to be clashing with these terminal blocks. And I've moved them all the way up to this edge here, can't go any more. And you can see it's just off centre. That central bit here needs to be in line here, but these are obviously in the way. But the beauty of Wago, rather than using two single terminal blocks, we can use one double terminal block. So that's going to enable us to save space and move that main isolator over to the position that we need. So you'll see me work through that in a second. Also, you'll see that this isolator had an additional contact on it, which I don't need. It's not a three-phase panel, so I can remove that, which you'll see is evident in a bit. Now I'm just getting an idea of where the main earth terminal and main neutral terminals are going to go. So there you can see I've now removed that extra contactor or contact. Thinking about where to position the earth bar, it took me a bit of time to sort of work out. So yeah, now I'm just replacing those two single terminal blocks with one of those double terminal blocks from Wago. So you'll see that I'm starting to create some space here to move this along. So yeah, ended up using 10 double terminals, which worked out to save me 10 single terminal blocks. So basically I saved that much space on the DIN rail, and as you can see now, that's what it looks like, with a bit of space if we do need to add additional terminal blocks. So yeah, as mentioned earlier, just continuing with the terminal blocks in a similar fashion on the BMS side. Now onto the 10 volt power supply and distribution terminal blocks. And these distribution terminal blocks, you never know when you first start, like me here, you never know how many are going to be needed. So you just sort of estimate and just make sure you've got some room to add additional terminal blocks if you need them. Now on to adding the PLC control modules. You can see just rearranging the BMS terminal blocks over here. I originally had this RJ45 Ethernet connection over here, and I didn't have any KNX terminals. So I just, moved that over, added the KNX terminal blocks, and then we've got space for expansion over here, whether it's additional PLC modules or additional terminal blocks. Now realizing that the DIN rail for the main isolator needs a gap in it, because the main isolator needs to move up slightly. And then I realised, I have to take all the terminal blocks off to remove the DIN rail, obviously. So I had to do that. I could have probably thought about this and planned this a little bit better. But again, it is what it is. So yeah, as you can see, I've just cut the bit out of the DIN rail, added this piece, and now I've got space for this to move up and down. And there's some holes within that isolator that will allow me to fix it on its own, which I will do later on once the panel's pretty much complete and I know how far up or down to fix it. And then the final bit here, guys, is just actually working out where the main earth terminals go in, where the main neutral terminals are going, or distribution bars, however you want to refer to them as. Yeah, and then obviously drilling, tapping, and fixing. So yeah, just some final images. So this main isolator needs to be moved up slightly, but we do that right at the end. So yeah, this is a really nice tool, drilling and tapping 2-in-1 tool. So you can drill, bad image, but yeah, you can drill the clearance hole and then go straight in with a tap that is just above on this bit here, and then yeah, just fix it straight away with your fixing screws. So yeah, this is what it looks like finished off. You've got that movement there, the gap in the DIN rail. This is fixed, neutral, bars or bar or distribution block. And you've got MCBs, transformers, contactors, overloads, relays, the BMS terminal blocks, PLCs, and the distribution blocks for 10 volts, 24 volts. And there's also some control circuits later on that get added here. So first thing when labeling components, guys, bit of electrical tape, and then I just mark it with a Sharpie each of those relays. Reason being, things might change throughout the project, throughout working through the panel. Relays might get moved, they might get sort of changed, so there's no point doing a label, I don't think, a professional label at this stage until everything's finalised. So bit of tape to start with. So next thing is I do the MCBs, and you saw there with a tape measure, just working out the length. And then for these ones, rather than sticking them on the actual MCBs, I'm going to stick it on the back plate. And the reason being is MCBs, they're pretty much fixed. They don't move about within the panel, but also they're things that are higher likelihood of being changed or swapped out or burnt out, or maybe you need to increase or decrease the size. So to save anyone having to do that, I'm just sticking the labels to the back plate, and then no one has to worry about relabeling an MCB when they switch it in or out. And then onto marking the components. So as you can see, I try and make them all the same length, all the same size text. Just, yeah, I like that consistency throughout. And what I'm using is a trusty Brother label printer here, and definitely recommend getting some tweezers. Just makes handling those little labels so much easier. And then Wago printer, we get onto using that a bit later. And then with the laptop socket, as you can see, I'm marking that with like a more hazardous label, pointing out that it's connected to a 10 amp MCB, so 10 amp max. Not that it's likely to be overloaded, but just think it's important to put that there. And then moving on to labeling the PLCs. Again, all keeping the same sort of font and consistency. And then moving on to labeling the distribution blocks down here. So they end up looking something like this. This was just a starting point. I ended up adding more later on. So this changes all the time. Again, that's why I use electrical tape and just a Sharpie for this bit here. Again, until they're finalised, and then we use a professional label like this, or a Wago printer. Okay guys, we're getting serious now. The first bit of cabling. So this is obviously doing the comms cable, and you can see first bit is just getting that Ethernet patch lead in there. I wouldn't recommend making up your own patch leads from cat cable. Just buy pre-terminated ones, far quicker, far easier. Just do that. Get a stock of various lengths and just use those. And then the next bit is getting the length for the K and X comms. And what I do is, rather than going, for example, this route and then starting the links here, I'll always go for the furthest path. And that's just in case anything ever moves around in the panel. It probably won't, but you never know. It's just good to have that extra length on there. I mean, when did anyone ever say that a bit of extra length wasn't a good thing? So what I'm doing is I'm coming out of these terminal blocks, or these ones here. This is the K and X ones, and following the Ethernet cable. So we're going along here, along here, along here, and then rather than terminating here and then doing the links, we're going all the way along here to this one and then doing the links. So that's obviously a longer cable run than going here to here. And that just gives us some flexibility if we ever move anything around in this panel. Like I said, it's unlikely in this panel, but this is just a practice that I use, and it's always served me well. So this next bit, as you can see, is just working out the link lengths across all these PLC modules. And you can see here that I've taken off the K and X connectors, and I'm actually just fixing them on my bench. So terminating the link cables on my bench at the moment. And then you can see here, I'm just fixing them one by one, and then the long length here. So that's what they look like. This bit here that you saw with the screwdriver, I'm just making sure there's not a sharp right angled sort of 90-degree bend coming out here and then swooping down. So as you can see, this is what they look like before I bend them down. And you can see here, this is what I'm doing with the screwdriver, just making sure that that bend is a nice curved radius rather than a hard 90-degree angle. This is solid core cable, so there's a higher chance that it could snap over time. So here you can see what they look like and where we're at now on the time-lapse video. So yeah, a soft bend down 90 degrees, and then yeah, just running along the bottom here. And then the final bit is just terminating that length of K and X cable from the terminal blocks to that first PLC module. So as you can see, do one end off the bench, heat shrink, cable tie, and then work out the length, and then do the same with the other end whilst in the panel. So yeah, bit of heat shrink, some cable ties as you can see here, and then just terminating in those K and X terminals. So yeah, a couple more pictures of what the links look like. This is what I'll do if it's solid core and I'm connecting to screw terminals, like with the extra power that goes down a K and X cable. These are the tools I use. So we've got a box of heat shrink here, Nipex strippers, ergo strippers, and yeah, pretty self-explanatory, the rest of them. And now here you can see the run of that final length of cable from the terminal blocks to the first PLC module. Bit more of a close-up going into the K and X terminals, and here's another shot. So some people might be asking, why am I not using K and X cable for these bits here? And the reason being is I'm trying to save space in the trunking and just make it easier for other cables to run. The K and X cable isn't very flexible, and it kind of gets in the way when you're wiring with more flexible tri-rated cable. We don't need that same level of protection like the screen and the sheath, because these links, they're not running against any other cables. The inputs on these rail quads, they're all extra low voltage control signals, so there's going to be no potential interference. And anyway, they're raised above these link cables. The only ones that you might be a little bit hesitant around, but it's absolutely fine. I've done this many times and there's plenty of clearance. But this module here, where there's these relay outputs, you might be switching some low voltage, so like 230 volt loads. Again, they're not necessarily noisy, so very low chance of interference, but that's where you might be a little bit hesitant. But again, like I said, it's not the best angle here, but these links run along the back plate, and you can see here, these are raised up above the back of the back plate. So yeah, there's never any issues, but it's far easier, and like I said, saves space than using lots of like the green cable here. It's just far easier to work with, looks neater, easier to fault find and service, etc. I don't want to go something like this, round like that with a green, and then in here, and then out with the green, in here, out. Like, it's just a nightmare to work with. So this is a far better, neater, easier way to work with K and X cable. Obviously, it depends on what system you're using, but certainly for K and X, this method works very, very well.
Guys, don't forget, if you want to go deeper or need help along the way, everything's inside the community. Resources, templates, extra guidance, all of it, and it's free. And it's built to help you get ahead faster. So jump in, link in the description.
Okay guys, on to wiring the main 230 volt feeds. So as you can see, just working out the lengths to start with. And not a very clear photo, sorry about that, but just getting the labels printed out. I also include the Protective Earth 1, 2, but I haven't got it here. Yeah, just getting those printed out off the Brother label printer. So yeah, just terminating L1 to start with on the MCB side. and terminating the neutral on the neutral bar side, and then terminating the protective earth on the earth bar side. But as you'll see here, so yeah, you'll see that I'm cutting out a section of the finger trunking just so the protective earth can go straight into flat into this terminal block. Before it was bending and I didn't really like it. It wasn't too bad, but I thought let's just cut a section out like that. So as you can see, it's just going straight in there now rather than bending. As you can see, this is what L1 looks like, pretty standard stuff. This is what the neutral looks like, protective earth again. And what you'll see on the other end of these feed cables, they're just left loose and they're not terminated properly, and there's an extra bit of length in the main isolator, and that's just to allow it to sort of move around until I finalise where it's actually being fixed. Okay guys, now on to the bulk of the wiring. So before we get into that, I just want to show you the tools that I use. So as you can see here, just standard cheapo Amazon ferrule crimpers. I recommend these Nipex strippers. They're really, really good. Only using 1.5mm cable for 99% of cables in this panel. So 1.5 single ferrules, also using some double ferrules. And then over here, this is a strip axe tool by Wiedmuller. It's an expensive tool, but if you're doing a lot of panel building, I would recommend using this, because it really does come in handy when you're in awkward positions and you've only really got one hand free, because what you can do with this is you can cut, you can strip, and you have one of these cartridges inside so you can crimp at the same time. So really, really handy tool that is, which I would recommend if you do a fair amount of panel building. So into the time lapse. So yeah, first thing is wiring this socket. So just, yeah, running the cable lengths, cutting those off, and then, yeah, terminating one end first and then back to the MCB, neutral bar and earth bar. Next bit is wiring the transformer, and as you can see, I made a little mistake, so I've just rewired the MCB going to the socket. You'll also see me in a bit rewiring the transformer. I got the wrong side. I think I might need my eyes tested. So yeah, the primary side is over here and secondary side is up here. So now just wiring again MCBs to the 10 volt power supply, single MCB to the power supply. This is also the point that I realised that I need to shift the MCBs along and add an additional breaker for the 24 volt AC coming out of the transformer. So I've just done that. Next bit, wiring MCBs to the contactor overloads. So main supplies to the contactor and overloads. Now going to the PLC, so supply to the PLC. Again, modifying the MCBs. I had the supply going into the first MCB, but that's being used for the 24 volt AC. So yeah, just rewiring that transformer as mentioned, and now doing the 24 volt AC into the MCB and then out to this distribution block over here. And then I'm just doing the supply from the 10 volt power supply similarly to the 24 volts just into the distribution blocks here. So yeah guys, just showing you some still images afterwards. So these are the feeds going from the MCBs. This is pretty much where we got to at the end of that time lapse. I haven't done the 10 volt distribution blocks here yet. You can see the coiled up cables that will eventually go to the terminal blocks, but we're going to be doing that bit last, so they're just coiled up there for now. That's a closer look of what the distribution blocks look like. So obviously there'll be some 10 volt supplies going in here, and these blocks here will grow over time. You never know how many distribution blocks you need. It depends on how the panel builder wires stuff. So yeah, you just need to make sure you allow extra space for expansion on this DIN rail. This will be the 10 volts. This is the 0 volts of the transformer. This is the 24 volts of the transformer. And then there'll be some additional blocks up here. These will probably grow a bit themselves, but then some additional blocks here for different types of supply circuits. I can't remember the numbers of them off the top of my head, but circuits that will be going off to the door, and there's another couple as well. So there's that coil that's going to go to these terminal blocks. Just a look at what the protective earths look like and the neutrals. Okay guys, so before we jump into the time lapse, just wanted to show you what I'm using to distribute constant 24 volt AC to various relays that need it. It's the same thing with the 0 volts as well to the A2 side of the coil. I use these as well. And again, Wago is what's great about Wago. They produce these jumper bars that just make it so easy just to distribute those voltages across relays without having to do additional wiring. So yes, it's extra cost in terms of hardware, but you save that in labor time, like 10 times over, I would say. So just before we start, I've jumped forward a little bit on this time lapse, forgot to press play. So I just want to show you what I'm doing. So at the moment, I'm just supplying all the relays with the constant 24 volt AC supply coming from these blocks down here. So as you can see, 24 volt AC, all these 100 circuits, they're being spread across the relays that need them, something like that. And as you can see here, as I mentioned, I'm having to expand those blocks immediately. So yeah, just adding additional circuits to those relays. I think this might be one of a 200 circuit possibly. Yeah, so 200 circuit. So again, if you look at the drawing, there's the 200 circuit, which is supplied from one single relay. So if that single relay is energized, then we then need to supply power to a load of other relays. And the best way to do that is just through a distribution terminal block or bar. And that's what I've done here. So you can see 200 circuit here. So that's where we're at on the time lapse at the moment. And what we've also skipped over is the 10 volt DC feed and 0 volt feed from the power supply. So yeah, as you can see here, the 128 circuit, 168 circuit going in here, that's the 0 volts, 168. And then the 167 circuit coming out of the 10 volt side into the 10 volt DC distribution blocks. And then what you'll see now is I'm now distributing those 0 volts and 10 volts to a couple of the relays that are switching that boiler control constantly on or constantly off, or constantly on to like 10 volts, or switching it to then be controlled automatically from the PLC, varying that 10 volts. So that's what you can see here. So yeah, this next stage, guys, I'm now doing the 0 volts to the A2 side of the coil on these relays. And you just saw there that I added those bridging connectors, and now I'm just adding those cables, distributing that 0 volts from the transformer. So yeah, as you can see, guys, the 24 volt AC constant supplies, they're 100 circuits, and they're feeding one side of the contactors because it's double pole, so feeding one pole of those contacts. We've got the 200 circuit, which is originally being fed from one relay, which is this one here. So it's being fed by a 100 circuit. And then once that's energized, then sends 200 out, and then we want to distribute that 200 across these relays. There's only 2 of them at the moment, 2 relays there. We've obviously got our 0 volts AC, which is being distributed here, and we've got jumper bars, and then similar thing with the 10 volts and the 0 volts of that 10 volts. They're being distributed here and here. So another angle here, guys. And again, more angles. You can see those jumper bars. Okay guys, so on to wiring the contactors and overloads, and this is a bit of a tricky one to talk through in detail from just this overview. But as you can see, starting off with the neutrals and the supplies from the MCBs, and these are going through the contactors. Then the overloads are connected to the contactors, and then they will then come out the end of the overload and then go off to the terminal blocks to run pumps, fans, motors, whatever it might be. Pumps in this case. And yeah, you can just see with the neutral, I'm just distributing it, going in here, double ferrule out to the next one. And it's important with these overloads that the full load current goes through all of the terminals on the overload. So if it's single phase, you've got to loop it back round so it goes through all 3 phases, which will enable it to trip correctly. This bit I'm just wiring out of one side of the normally closed contact into A1. So that's how you correctly wire an overload relay. It needs to go through the normally closed contact of the overload into the coil A1 terminal of the contactor. So if that trips out, it then cuts out the power going to the coil energizing the contactor. That's really important that you understand that, because I've seen many times people wiring them incorrectly and it can cause major issues, pumps overloading, overheating, potential fires, etc. So it's important you know how to wire these correctly. And then on the normally open side of the contact on the overload, that will then be going to a relay, energizing that relay, and then we've got 2-pole relays, so one will be going off to a light to say that it's tripped, and the other side will be going to the PLC to let us know remotely that it's tripped. Or we can program anything else we want off the back of that input. So yeah, quick overview from this image. So like I said, you've got the single phase coming in on L2, going out and then back around into L1. You've got neutral just on L3. This isn't wired yet because it's going off to the terminal blocks. That's something we do later. So that will then be coming out of T1 off to the terminal block, and then similar with the neutral, out of T3 off to the terminal block. So that's the power going to the pump. We've got our normally closed contacts here. So we'd have a supply of, in this case, 24 volts AC. I've not done that yet because that's coming from the door. That'll be coming in here, normally closed, out on 96, cable 177, which you can see loops round to here, A1. So when that's in a good condition, that's closed, things haven't tripped, everything's healthy, power can pass through that and into A1, energizing this contact, and this is obviously going to 0 volts on A2. If that trips out, if it overloads, depending on what we've got it set to here on this dial, that then opens, that goes open circuit, which cuts the power to this contactor, which in turn cuts the power, or the power stays here, but it cuts the power on this other side, going off to those terminal blocks and off to the pump in the field. And then on the normally open contacts here, which are normally open in a healthy condition, when that does trip, they will then close, and then that will be going off to our relay, which will energize, and then we can have various things happening off that relay. In this case, we've got it energizing a light on the front of the panel for a visual representation, and then also with a different voltage going into the PLC to let us know and send a push notification, an email, text message, or we can just program something off the back of that input telling us that this pump has tripped out.
You're probably bored of me saying this, but everything that I'm showing you here in this video, you can access within the community. So extra resources, support, training, go and grab it. The link is in the description.
Okay guys, so the first cables of the PLCs I'm doing are these grey 0 to 10 control voltages that are going to, or they're going via a relay first, but then going off to the terminal blocks that are going to be controlling the output of the boilers, varying how hot they are basically. The next bit, which we'll see in a second, is the closed loop digital inputs coming from the relays, but at this stage I'm just working out the bus connections, the link connections that Wago have, just so I'm not using loads of cables coming from the PLCs. So just working that out now. And now I'm just working out that first couple of lengths, or the longest possible length, and then I'll take that off, work out how many cables need to be cut that off the bench, do all the numbering, the idents and stuff, and then, as you'll see, start bringing them back in and start wiring them up. So yeah, here you can see the bulk of them I've already pre-cut, pre-identified, and just chucking them all in at the same time, and then do the same on the other end where the relays are. It's just far quicker doing it that way. And the reason for these cables is just when a relay energizes, when something trips out or is running or is in fault, that sends a signal to the PLC to let us know its status. So yeah, as you can see, the first cables were these 0 to 10 volt outputs for boiler 1 and boiler 2. They're going via some relays where you can see the greys here. We've also got some additional greys coming from the constant 10 volts, which is for when the cam switch is set in hand, so manual, and we're just using a constant voltage from this power supply to feed the boilers rather than having automatic control coming from the PLC. So yeah, these relays here will be energized based on what the cam switch on the front of the panel is set to, whether it's in hand, whether it's in auto, and that will in turn energize these relays accordingly and then switch it from constant 10 to a variable 0 to 10. So yeah, you can see here all of the cables are kind of running together. Makes sense just to obviously do things from one point in the panel to another, and if you can cut them all to length, roughly the same length, and do it off the bench, that makes sense too, and just makes things a lot easier. So some more photos. There we go. More photos. And then as per usual, guys, just obviously marking off the cables once they've been wired, highlighting them with a highlighter. Okay guys, so the couple of 3-position cam switches up here have already been wired, and you can see I'm just starting to do the 3-position ones down here on this side, and it's pretty simple. It's just a feed coming in, looping in out to one side of the contacts. So that's the first bit that you'll see me doing. Also, you'll notice these 2-position contacts or switches or cam switches, 1, 2, they originally only had one contact on them. So because it's for pump 1 or pump 2, we need to have a second contact on there. So I'm just adding those on here in the video, or have done. And then it's a similar thing with these contacts. You're just bringing a feed in, looping out into the next one, and then over here. And then from here on out, it's just lots of long cables going into the other side of the contacts on the 3-position switches and the 2-position switches. So yeah, not really much to see. So I'll just talk you through what that looks like. So this is it when it's all done. And what you've got is you've got a cable coming in, 24 volts coming in on, let's just say, well, let's talk about the 200 circuit on these ones here. So 200 circuit, which is 24 volts coming into this side of the contact, looping out to this side of the contact, out, and then over here, this side of the contact, looping out into this side of the contact. These are normally open contacts, so NO, normally open. So when we haven't switched them, they're open, normally open, and they're green as well. That usually, from what I've seen, all green contacts are normally open. All red ones are normally closed. So you can get normally closed ones if you need them, depending on how you're doing your controls, but these are all normally open. So what will happen is we got voltage here, we got voltage here, and the system's just looking now for someone to switch that to hand or auto. At the moment, in the middle, where nothing's engaged, none of these contacts are enabled, in the middle it's off. So we switch it to hand, then we've got the power, this closes, and then we've got the voltage or power running through here to this cable, and this cable then runs back to the panel, and I think in our designs, in our system, it's energizing a relay. For the vast majority, 99% of these, it's then energizing a relay, and then we're doing other things off the back of that relay. So we're in hand, we then move it, say then we want to put it into auto, so we move it back through off, so that's now open again, it's in the off position, and then we close it on auto, and that then engages, closes this contact, and it's exactly the same thing. Then that cable So it passes through here, voltage, power, whatever you want to call it, into this cable, and then this cable goes back to the enclosure and then energizes a relay. So simple stuff, guys. Now let's move over to the 2-position contact, and it's exactly the same principles. We've got our feed coming up here. It's a different circuit on the 2-position switch, and it's linking into the first contact and then out to the second contact. And this is only ever, in our system, pump 1 or pump 2. So I think you've got this side enabled at the moment, being that we can just about see that green contact. We can't see it over here. So at the moment, it'll be like voltage will be coming up here. Nothing's happening here because this is open, normally open. It's not switched on this side. So nothing's getting past here. But on this side where it is switched, that's closed now. And it's passing the power voltage back down 127, and then cable goes back to the panel and energizes a relay. We switch that to pump 2, then this opens up, so no voltage, and the same principle happens on this other contact, and then that cable sends power to another relay, and we do other things on that relay. So that's pretty much it, guys, for the door. As you can see, there's a lot of cable being used here. So do not underestimate the amount of cable needed if you're wiring stuff to the door. So I think I got through 2 rolls of 100 and a little bit more. So yeah, that gives you some idea of how much cable you need to factor in for this size panel or amount of things happening on the door. You need to factor in that sort of amount of cable. So make sure you're stocked up if you're doing anything door related. Okay guys, so onto the terminal block wiring now, and you can see basically what I do is I just work my way up from one end to the other, depending on what side the terminal blocks are on, and yeah, just basically go one through to whatever the final block is and add in the cables. And what I try and do is, unless they're already connected like they are here in the MCBs, the bottom of the MCBs, where you can see they have to go back up this way, up here, I'll just cut the length of cables that are roughly going to where they need to go. So as you can see here with the 0 to 10 volt control signals that are going to the relays, I'm just cutting the lengths. I think there's 4 cables there. Cutting the lengths, putting them in here, keeping them secured with these. Either use the fingers of the finger trunk in, or I'm just using self-tapping screws here. And yeah, just you can see they're all swooping along and then going to where they need to go. And these will be terminated into the relays here. So here you can see that they've now been terminated. And yeah, I basically just do that all the way along for each terminal block. There's another image. You can see with these MCB ones, they're just going up and wrapping around here to each terminal block. I did run out of terminals on this neutral bar to feed outgoing pumps and what have you. So I did have to add my own little Wago buzz bar here. Thing to be aware of is just to make sure that the cable that's taking all of these neutrals, so these neutrals are obviously coming from the terminal block, going in here, being distributed on this buzz bar, and then coming back to the main neutral terminal bar. So what you need to make sure of is that this cable here, this single cable, or maybe you're using a couple of cables, but whatever it is, that's got enough current carrying capacity for the additional circuits that you're adding on here. It's something to be aware of. Then I'm just doing the outputs on the outbound side of the overloads of these contactors, and they're going up to the terminal blocks too. So actually I'm coming down this way and then in, and you can see that's it pretty much finished on the power side. So I've got it split sort of power side and then BMS control side. You can see they all overlay each other. So when it comes to servicing, it makes it very easy just to follow mostly where these cables are going. The MCBs are a little bit different. They're going underneath these cables, but the majority of them, they're very easy to trace and find out where they're going. And yeah, now it's basically exactly the same on the BMS side. Some close-ups of the power side. You can see how they're all swooping along, easy to trace out. And then yeah, exactly the same on the BMS side. These are very short runs. So yeah, I just cut all these cables roughly to length. I usually go from the furthest point here to the furthest point over here, and then I'll just cut all those cables the same length, put the idents on them and ferrule them, and away we go basically. And then you go to the accepted circuits. They're going off here to relays, relay control, and yeah, that's basically it, guys, for the terminal blocks. Okay guys, so on to the final bit of mechanical alteration and fabrication, and this is where you've got to be really, really careful. It's always a bit of a squeaky bum moment for me going through this, so just take your time, be very careful, double check, triple check your measurements before doing any drilling, because at this stage, if you've been through all of this panel building and wiring, and then at this stage, if you mess up the mounting of the door isolator, you're basically going to have to do or replace the door and do the wiring of the door again, and all the fitting of the cam switches, lights, plates, etc. It's just a right palaver ball ache that you don't want to do. So it just pays to take your time. And the first thing is RTFM. Read the fucking manual. All these different door isolators and main switches are different. Like, even if you get a couple of very similar looking switches and isolators from the same manufacturer, like ABB that I'm using, there's so many different types. So don't ever assume that the one that you used last time, unless it's exactly the same part number, it's going to work again in the same way. So be very careful, read the manuals and take your time. So yeah, obviously I've read the manual and it tells you all the sort of measurements and stuff in here. This is the shaft that I was using and the switch, and what you want to remember to comply with BSEN 60204 is you want to make sure that when the panel is on and live, that if there's no other like door catches and door locks locked, that you can't open the door. Basically, when you switch it on, it locks the door into the switch, so you can't open a door when it's live, basically. So yeah, this is the main switch that I'm using, both from ABB. Then the first step is basically cut your shaft to length, and the details on that are in the manual. Next, what I've done, and people do this lots of different ways, the way that I did it on this system was, firstly, I wanted to be absolutely sure where it was being mounted and what it looked like, and that it was nice and parallel along this face of the door plates, because I was mounting the switch later on rather than at the start, because I wasn't exactly sure where it would line up here if I mounted it on the backplate first. So I reversed it, and I don't always do this, but so I went with the actual switch being fitted first, as I said, so it was nice and in line with this here. So I just wanted to double check that, and then I marked the center hole, and yeah, just you can see marrying it up there, just making sure that it was the right size and looks visually okay. And then for me, I've just got a cheapo laser level. I don't use it very often, so I'm not going to fork out on an expensive one. But annoyingly, it doesn't have a magnet, and so I can't stick it to something metal. This panel here would have been great. And it doesn't have a tripod. So I've just had to get it to the right height using this, as you can see here. And then, as you can see, I basically got it bang in the center with a little bit of a drop. Because what happens is the shaft, when it's in the switch on the back plate, it drops a little bit because it's however long, 200 millimeters or so. It does drop a little bit underweight. So I always drop it by about 5 to 7 mil. That tends to work out okay, but don't take my word for it. It will depend on the length of the shaft and other things, but that's typically what works well for me. So yeah, got that all centered up, and we want to make sure that this isn't going at any angle, that it is as perfectly square to the panel door as possible. Really important. And then yeah, just a close up, just checking that it's looking okay. Then I open a door and I can see now where the center of the switch needs to go, the switch isolator or the actual main isolator. And then you can see, yeah, there, I'm now checking that it's got enough room because it was quite high up to this trunking. So I'm just making sure that there is enough room to get these main incoming cables in as well. And as you can see, that's all good. Then I just want to protect these lights and cam switches when I'm drilling. I don't want any swarf getting into them. Tools that I'm going to be using. So I will be doing a center tap, and then I'm just using a hole saw here. I can't remember what size it was, but those are the tools I'm using. Also, as you can see here, I'm making sure that there's no swarf going inside the panel. This is even more important. So yeah, make sure no swarf's getting in any of the electronics or around any of the cable terminations. And then, very nerve-wracking moment, but I went for it, and drilled the hole saw, another angle there, and then I'll deburr it. So I'll just use a deburring tool and then fit the main outside switch. And then I just put the shaft inside and just had a look like into the switch on the door side and just see, I had a look where it actually lines up based on where I positioned the switch earlier on. You can see because there's a bit of a hang through the weight of it, it's a bit lower. There you go, you can see that there. And now, I can't remember what I did here. I think I was holding it in place. But yeah, you can see that's basically what you want when we fit the switch. So again, I'm just making sure that there's no swarf that's going to go into any of the components. This is a problem and a bit risky when you're doing this, i.e. mounting the switch later on the back plate. You've got to do things like this. Obviously, if I'd done it earlier, I wouldn't have all the other components and wiring done. So just something to be aware of. And you can see my little mounting holes are here. So 1, 2. So drilled those, tapped those, and then here, what am I doing here? I think at this stage, I've got it mounted. I've got the shaft in, and now I'm just getting the right length of the shaft. Again, just check the tech manual. Yeah, and that's it. But yeah, as I said, just be very careful. Take your time going through this. Double check your measurements, triple check your measurements before drilling.
Do you want to get your hands on the diagrams, the wiring schedules, the step-by-step checklist that I'm using here? They're all inside our free community, plus additional support if you get stuck. So hit that link in the description.
Okay guys, so onto the labelling now, and as you can see here from this image, the two things that I use for my labelling is the Wago printer and the software to go with it, and pretty standard. I think most people will have one of these brother printers. So those are the two things I use for labelling control panels. So yeah, as you can see here, this is the software for the Wago printer, and it just makes labelling terminal blocks so much easier, and you can use it for labeling all sorts of different things. I'm only using it at the moment for terminal block labeling because that's the only media that I have. I would have probably done more labeling with it, but I don't have like the different types of media to print on at the moment. So yeah, this is what it looks like doing the designs for the terminal blocks. It's really, really good. You can see here, this is how the setup of it is. You've just got a reel of media here. It goes into the printer, and then you connect it to your computer and use the software to do the printing and whatnot. There's another angle. Highly recommend getting some tweezers for this part. It's really, really fiddly and trying to stick labels. This is more so for the actual labels in the brother printer. It's really hard to actually get them stuck down to the back plate or trunking when they're really small labels. So yeah, highly recommend getting some tweezers as well. I typically use this 45-degree angled one. On the power terminals on the left hand side, I didn't actually use the Wago printer because, as you can see, there's lots of different levels here, and I'd already put these standard idents or labels there, so I just left it. Also on the other side, the BMS side, you can see in the drawings that I have labeled them BMS 1, 2, 3, 4, etc. So yeah, it made more sense here for me to actually label them BMS and then the number. There's not so many different levels here, so I didn't have to cut lots of different individual labels, so it made more sense doing it on this side. So yeah, BMS 1 through to 18, and also the KNX label as well for our outgoing KNX cable. I've done a similar thing for the neutral bar or neutral buzz bar, and then same thing for 24 volt AC, the 200 circuit, and the 10 volt DC as well. And I've also just added in the circuit number as well. Also use the Wago printer for the relays. So all the relays from 1 to 33 is just one continuous label. That was really good. So that's going running across all the relays. Now coming to use the brother printer, this is how I'm labeling my MCBs, and I'm doing it on the back plate because I have labeled individual MCBs before, and MCBs are usually the things that get replaced. So I just think it's and then if they get replaced, then they don't always get replaced back with a label on them. So yeah, I've just put the MCB label on the back plate here. 1 through to 15. Also recommend putting a main incoming earth point, and it's pointing to this terminal block here, just so it's absolutely 100% clear where, that incoming earth connection should go, and not getting confused with putting it on this bar here, just really for the commissioning or installation team. Also, accepted circuits. So these are orange cables are accepted circuits, which basically means that they are, even if the panel is switched off and isolated, these circuits are fed from another supply, and in our case is the overdoor heaters, and they could be providing a 230 volt supply or signal or whatever you want to call it back into this panel, even if the panel is switched off. So this is where it's really important to let people know who are working on the panel that even if the panel's off, these are still 230 volt live potentially. So just being very clear with that label. Warning, potential live 230 volt AC circuits when system isolated, terminals 9 to 12. So 9 to 12. I put this here because it's very, very clear, but it is on the trunking, which over time trunking does get lost, or that it might not get put on in the right place. So I've also just added a smaller label here. But what you've got to bear in mind is this is probably going to be covered up with outgoing cables once it's commissioned. So people won't necessarily be able to see that as easy. So basically that's why I've put 2 labels there. And then this is kind of just an extra nice to have, really, just to point out to the commissioning installation guys that this top piece of trunking is for the electrical installation cables. So I've done that on both the power side and the BMS side. Also, I've got a load of these like pre-made up stickers from Cablecraft. So whatever the voltage is of your panel, in this case it's a 230 volt panel, but it might be in your case a 410 panel. Just make sure that you put this danger voltage label on the front of your panel, matching whatever voltage it is. And also just marking the bonding points, their earth points. And that's basically it for the labeling. And this is the panel all labeled up, and pretty much finished. I didn't mention, we've already been through the labeling of all the components. Just as a reminder, that was using the Brother printer, and I've also just got a label here for the laptop socket, 10 amp max laptop socket. Okay guys, so now we're going to be going through all the red pen that I've put on the drawings as I've been working through the control panel, and we're now going to update the designs basically. Really important part to the whole process is to make sure that we actually do update the drawings. So that's what we're going to do now. I've scanned the drawings in with all my modifications and red pen. So you can find that if you go to the resources in the Google Drive and drawing pack, and then you should see BMS school refurb red pen, and that will bring up the scanned in document that I've been red penning and modifying. So we're going to go through each page step by step, and I'm going to then update it in CAD, and then at the end of this we'll have a final CAD file and final site version, all the schematics that can then be made into a site pack. You can see here all MCBs are 10 amp C type. Other note here, check current draw total of equipment connected to the neutral Wago block. So I've already checked that. That's all okay. Also, it says down here, KNX PLC inputs are white, accepted circuits orange. So that's the first thing I'm going to do, is I'm just going to change all the MCBs, or the labels of all the MCBs on every page. And I'm going to do this as well on every page. So I'm just going to pause you there and then I'll come back. Okay guys, so I've done that. I've done all the MCBs. I've updated all of those to 10 amp C types on every page. And I've also updated the cable colors. KNX PLC inputs are white and accepted circuits are orange. So now let's go back to page 1. And what I'm going to do now is I'm going to connect this test light of this 24 volt AC healthy. Missed that out. I'm going to just update the label here, and I'm also going to update the relay numbers and the terminal block numbers. So I'll do that now. Okay, so that's the test circuit extended to this light here. I've updated the terminal block numbers and the relay numbers. So next page is pretty straightforward again. I'm just going to update the terminal block numbers. I'm going to have to do that on every page now. And I think on every page I need to update the relay numbers. So what I'll do is I'll do that on every page now, and then I'll come back when something a bit more interesting, worth going over, comes up. Okay, so that is the terminal blocks all updated throughout, and the relay pole numbers updated throughout. So the next thing I'm going to do is on page 3, and I'm just going to add these numbers which tell you which part of the relay these cables are going into. It got a little bit confusing when I was wiring it, so I think it's best practice just to add those numbers in there, and that will tell you whether it's the common or the normally open or the normally closed. You can see it here visually, but I think just let's do things properly, and let's add the actual identification of the relay terminals in here too. So that's the next thing I'm going to do. So yeah, that's the numbers added to the relays on page 3 and page 4 here. I've also added this symbol here to indicate that the 0 volts of the 10 volt power supply is connected to earth. So that's the other thing I've done. Now moving on to page 5, got a few bits to do here, and these are some, I'd say, major alterations. So as you can see, I've missed out a couple of cable identifications, so I'm going to add those in over here. But over on this side, I was intending to use can I zoom in? There we go. An MPCB rather than a contactor and overload, just to differentiate using the two for this project. But I ended up just using 2 contactors and overload. So this whole section here, and as you can see over on this side, the logic of the relays and the overload is getting added in. So it's basically I'm copying what's over here and moving it here basically, or replacing it. So yeah, you can kind of see here what needs to be done. So I'm just going to do that in CAD now, and then we'll come back and I'll show you what it looks like. Okay, so as you can see, that's now been pretty much copied from over here to over here, and then I've just updated all the labeling, also updated or changed the contacts over here for the overloads. Also, because MPCBs have their MCB built in, I've also added an additional MCB here. So we've got MCB 9, 10, but I've had to now update all of the relays further down. So we've now got a total of, I think it's 15, sorry, MCBs, not relays. We've got a total of 15 MCBs now. Now on to page 9, and just something else to point out, I've had to update the identification of the cables leaving all these MCBs now upstream from where we just were, just so the labels match the MCB number, because I'm using 5 to indicate that it's an MCB, and then the number of the MCB is the label on the cable. So 514 is MCB 14. So I've had to do that on every page with an MCB from there on out. Next bit is I'm just removing these cables feeding the differential pressure switches and the thermostats, because what I'm actually doing in the panel is I'm just using a little Wago terminal bridge. I'm not actually using a cable, so I'm just going to remove those. So yeah, as you can see, I've removed those drops down here, and I've just basically bussed this constant 24 volt supply this way over here using what's actually physically being used is those Wago bridge connectors. So on to page 10, and there's just a couple of bits here, just correction of a page number. I need to change the identification of this cable. Also, we've got some accepted circuits over here controlling the overdoor heaters, or the relays for the overdoor heaters. So I need to make sure that these cables are indicated that they're the color orange. They're not white like all the other cables are for the KNX PLC, because they're accepted circuits. And also I need to remember when I do my labeling to add a warning label indicating that these terminal blocks and these cables or these circuits are potentially 230 volt AC live even when the main isolator is off and the panel is isolated, because these could still be feeding 230 volt AC into the panel. So that's what I've written this reminder here. Okay, so that is the indicators or the modifications indicating that these cables are orange. And I've also just put that label in there, which I'll also stick within the panel by these terminal blocks. Another quick thing that I've just done, as you can see here, for whatever reason, lapse of concentration, forgot to put, the heat emitter pump 1 fault signal into or drawn into the PLCs. So I've just added that in here now. So that's sorted. And then the final things is really on the door plates and on the internal panel layout. So firstly, I forgot to put in a lamp test button, and also I ended up reordering the plates because what was happening is we were having like green on the left hand side, and then you can see here on the double plates, I can zoom in, on the double plates, it wasn't adding up, it wasn't consistent. It was green, 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 red, and then on this side, red, red, green. So that really annoyed me. I didn't have to do this, but I basically ordered new plates, so switching those round so it is consistent all the way down. So I'll do that in CAD in a second. And also, just to make life easier for the person building the panel, it's always handy just to write on these bits of trunking what the sizes are. So on the larger pieces, there'll be 60 by 80, and then on the smaller pieces, there'll be 40 by 80. So I'll do that now. Yeah, so that is it, guys. So I've just changed the labels, added that lamp test, changed the labels on the double plates, and added this little note on the internal panel layout for the trunking sizes. And that's it. That is the red pen or red penning all updated and into the final design and schematic documentation. Okay, so onto the MCB chart and panel details. So if you open up the resources folder and go to drawing pack, you should see both the MCB chart and the panel details within that. So you can use this template for yourselves, just obviously change the details in there. So for the panel details, it's pretty self-explanatory. What I've got is the site, the job number, the panel reference. So in this case, it's a mechanical control panel, and there's only one of them, so that's that. The incoming isolator details. So this is the main isolator switch is up to 63 amps. It's 230 volt AC and it's single phase neutral 50 hertz. Details of the panel manufacturer. So me, obviously, and the date. And then with the panel testing, so the electrical safety. So I've checked that and it's all okay. And also the functionality testing that we've been through, or we will go through, depending on where you're at in the training, in the control panel test specialist, so of which is all passed as well. So that's what goes into the panel details. And like I said, just change these values to match your project, and then you should just be able to print this straight out. What I did actually is I changed the percentage to 80%, and that printed out much nicer. So just a little pointer there. And then the MCB chart, again, self-explanatory. So same as the previous one, site, job number, panel reference. And here it's just a nice quick place to look at of what all the circuit breakers are doing, what number they are, and what type they are and what size they are. So all self-explanatory. And it's in the same format layout as the previous one. What I would tend to do is I would have these printed out on the Wago printer, but I don't have the media or the sticker size for them at the moment. So this way it just makes it easier for everyone to access. This is just done on Excel, and then you can just print it out on a piece of A4 paper and then laminate it, which is what I've done here. Let me show you. So this is what I've done. I've got a laminator, got some laminating pouches. I've printed them out on the printer, so just standard A4 paper. I've cut them out. Also, I use this foam double sticky backing. So once they're laminated, I'll stick this on the back and I'll cover as much of that as I can. Can get sometimes a little bit hot inside panels, and depending on what environment they're in, can get a bit warm and then the glue can come unstuck. So just use as much as you can if you're not using a proper sticky backed sticker. And then once they're laminated, they're stuck in the panel like this. I'd always stick the MCB chart inside the panel. If I've got like just a regular sticker, I would probably put the panel details on one of the sides of the panels. But in this case, because it's laminated and I don't want it potentially being knocked off in transit during the installation, commissioning, whatnot, I've just put it inside as well. So it doesn't really matter. But yeah, that's where they're stuck, and that's what it looks like. Okay guys, so now the final thing is to put together a site pack and print it out and create a digital copy. So what's included in the pack will depend really on your own preferences or what the site requires. But what I would include in my site pack, and first of all, before we get into that, what do I mean by a site pack? So basically a collection of all the design work, documentation, tech manuals, schematics, floor plans, etc. All of this documentation that's going to be helpful for engineers on site who are either going to be doing the commissioning initially or fault finding and doing service and maintenance work later on, and also the client for their own records as well. So yeah, anything that sort of comes under that remit really. And obviously it's good for us as the service provider manufacturer to have all of this in one place too. So in terms of like the digital copy, this will just be on a USB stick and also on our computer, also in the cloud somewhere. So USB stick, I would typically put in the actual physical site pack so the client can offload all of those files onto their computer and into their cloud system and backup system if they choose to. But in terms of the physical pack, what I would suggest is just something as simple as this, is just get a see-through plastic wallet, A4, and then when we print out in A3, I recommend printing certainly the schematics out in A3. You can just fold them and they fit nicely into here. So that's what I would do, nice and simple, not too expensive either, and just put a sticker on the front of the wallet for appropriate to the project. So that's the actual physical site pack. Now what goes into that is really up to you, but for me, I would certainly, the first thing, obvious thing, would be the schematics. So I would print off all of the schematics after we've done the red pen and the updates. Once I'm happy with all of those and they're done, I would print all of these out in A3 and add them into the wallet. I would create 2 copies of the schematics, one neat copy for the client and then one other copy that it doesn't matter so much if they get dirty, and that's for the commissioning team when they're on site basically getting things up and running. They will get creased, they will get torn, they get covered in dirt. So that's a set for them and a nice clean set for the client. Now the next thing I would always include would be the schedules. So the MCB, the input, output and the relay and contactor schedules, I would add them in as well. They're just nice to have, easy for engineers to reference quickly. So those would be included. So the MCBs, the inputs and outputs, the relays and the contactors. I might also choose to include the bill of materials. So if, depending on how you want to run and set up your business, if you want the client to always come to you for any parts, hardware, if things break or need maintaining or whatever, need servicing and they need new parts, then perhaps you don't want to share this bill of materials with them. It's not to say that they couldn't go see the part in the panel, for example, and go and find that online. It's probably a better idea just to provide a better service to include the bill of materials within the site pack, just so they can easily find the exact part if they ever need to swap it out. So that'd be the next thing. I would also recommend adding in any floor plans and hydraulic schematics as well. So anything issued by the M&E designer or the client, this will be really helpful for commissioning engineers whilst they're on site, just to get an overview of the project. So yeah, I would include all of these in there as well. Now, tech manuals. Now, I wouldn't necessarily print all of these tech manuals out and put them in the physical digital site pack, because as you can imagine, there can be lots of tech manuals, and yeah, it will just get out of hand, and most likely not all tech manuals are going to be referenced anyway, or tech manuals are so big you only tend to have to use or need 1 or 2 pages out of a tech manual anyway. So I wouldn't be printing these tech manuals out, but in the digital copy and the USB copy, I would put this folder in there, so at least they can the client has a digital copy of all the tech manuals used. And then finally, moving on to the testing and commissioning sheets, depending on whether you've produced these sheets to say that the panel's tested out okay, you might want to include those in there as well. And that's pretty much it for the site pack. Really, it depends on your preferences, what the site requires, what the client wants, but that's generally what I would include in the project that I design and build and then commission.
And look, if you're an electrician wanting to upskill, or an engineer breaking into controls, or even a business owner wanting to train your team, this training is just the start. You can join our free community where you'll find free trainings, additional resources, and our support where you'll be able to make progress much faster. So you can find that link in the description. I'll see you in the community.